we couldn't fit all the first problem in 10 minutes, so on the second tape I'm going to do the second problem, and then we're going to do a problem from your book. So this is example number 2. Mr. Rabbit hopped off toward the briar patch, poor Mr. Rabbit, at 10 kilometers per hour at 10 a.m. At noon, Mr. Wolf began the chase from the starting point. If he caught Mr. Rabbit at 2 p.m., how fast did he run? So, looking at this problem, we know that the distances are the same. They started from the same starting point, and when the wolf caught the rabbit, that was the end, so they had the same ending point. So we're going to draw, you always start out first drawing your 2 parallel lines and setting up your picture. So first we have poor Mr. Rabbit. He started from here and he hopped his way merrily across here until he got caught by the wolf. So we have, that's the distance of Mr. Rabbit, is right there. The wolf started at the same starting point and he ended when he caught the rabbit, so they both ended at the same time. So this is the distance of Mr. Wolf. We can see their distances are the same, so we set up our equation. The distance of Mr. Rabbit equals the distance of Mr. Wolf. That doesn't help us any, so we need to go back to our formula, distance equals rate times time, and substitute for the distance, rate times time. So we have the distance of the rabbit, so that's the rate of the rabbit, time of the rabbit equals the rate of the wolf times the time of the wolf. Now we have some variables to work with. Now we go back to our problem and we write down everything that we know from the problem. We have that Mr. Rabbit, that his rate is 10 kilometers per hour. So I'm going to write that down. The rate of the rabbit equals 10. We'll put in the units at the end. We don't know the rate of the wolf. That's what we're trying to figure out, how fast. The speed is our rate. Now we can figure out some other things. We know the time. We know that the rabbit started at 10 a.m. So I'm going to put Mr. Rabbit's rate right here, 10 a.m. We know Mr. Wolf started the same place at noon, so we're going to put his rate right here. We know the wolf caught poor Mr. Rabbit at 2 p.m., so both of them end at 2 p.m. Now we know how long. Mr. Rabbit went from 10 to 2. He hopped a long time. He hopped for 4 hours. So the time of Mr. Rabbit is 4 hours. The time of Mr. Wolf is from noon to 2. So his time of Mr. Wolf equals 2. Now we have 3 variables to plug in. That leaves us with only one unknown, which is the rate of Mr. Wolf. So plug them in. We get the rate of the rabbit is 10. The time of the rabbit is 4. We don't know the rate of the wolf. We know the time of the wolf is 2, so I'm going to put that first. Time is 2 times the rate of the wolf. And all we have to do now is solve for the rate of the wolf. So that's 40 equals 2, rate of the wolf. Divide both sides by 2, and we're going to get the rate of the wolf equals 20, and it's in kilometers, kilometers per hour. Kilometers per hour. And that is your final answer. So what I want you to do is we're going to work on practice problem A in your book. So get your book out, go to practice problem A and see if you can get it. Check your answer in the back. Stop the tape, stop the video while you're doing the problem, and then when you're done, turn it on. Don't cheat. Make sure you try the problem on your own. Turn it off now. See if you got it right. Draw your pictures. Practice problem A says Elvira made the trip on Tuesday. David made the same trip on Wednesday. So we know the distances are the same. Elvira traveled at 14 miles per hour. That's her rate. David traveled at 21 miles per hour. That's his rate. And then it tells us his time. His time was 3 hours less than Elvira's time. How far did they travel? So I just wrote everything here. The rate of Elvira is 14 for Elvira. The rate of David is 21. We know the time of David equals the time of Elvira minus 3. So this is the tricky part. So that part is, hopefully you got this part. Now we just need to plug everything in. We can set the distances equal, then we substitute rate and time, and then we plug in everything we know. So we get 14. Time, we're going to leave in the TE, time of Elvira. Rate is 21 of David. Time of David is time of Elvira minus 3. So we get 14 time of Elvira equals 21 time, my battery's going dead on my camera, equals 63. So we're going to get, if we subtract 21 from both sides, or we can subtract 14 from both sides, and we're going to get 63, add the 63, equals 7 time of Elvira, and we divide both sides by 7, and we get the time of Elvira equals 9. But we don't want the time of Elvira, we want the distance. So we have to go back here, and we know the distance of Elvira equals rate of Elvira times the time of Elvira. Distance of Elvira, her rate is 14. Her time is 9. So we get the distance of Elvira equals 126 miles. So hopefully you already got that, and that was just a quick review. That's it for lesson 22.